So hello guys, welcome to my YouTube channel. This is Learning with Ganesh, and today I am going to explain you the arrangement of electrons in atoms of any elements. Now, arrangements of electrons. I am just explaining you a simple schooling manner, not in a college level. So one way we can say a small step, a primary stage of electronic configuration. Electronic means electrons and configurations means arrangement, the arrangement of electrons. But here up to the school level, I am just explaining you according to the CBSE syllabus class 10. What is that? So for this, what we have to go through the atomic numbers of different elements. So in my previous video, I have already given you the atomic numbers of first 20 elements with a simple trick. So if you know that what are the atomic numbers of what elements, suppose atomic number of hydrogen is 1. 1 means what? See, suppose this is an atom of hydrogen, inside it's a nucleus. In the nucleus, and the electrons will arrange in such a manner. So here, two things present in the nucleus, that is proton and neutron. Protons are positively charged particles and neutron is no charge, but electrons are electrons are negatively charged. Now what happens of any element? If I'll take, suppose if I'll take helium, Helium, okay, helium, the atomic number of helium is 2. Now here is a center part of the atom, which is nucleus, contains proton and neutron. How many protons? See, the atomic number of helium is 2. Similarly, the atomic number of any elements will be the number of protons which is present in the nucleus. Now, so see, for atom there are 3 subparticles: electron, proton and neutron. So here we got proton and neutron. Neutron has no charge, proton has positive charge. Now we are taking, this is the example of helium atom, so it contains 2 protons in the center. Now what about electrons? So electrons will revolve around it as in a similar manner, just the solar system, Earth, stars, as revolves around the sun. Similarly, the electrons keep on revolving around its proton and neutron. So in what way? You see, this is the first path, and this is called shell. This is called shell, and generally it is known as K shell, or we can say shell number 1, or we can say K shell. So in K shell, you see, the maximum number of electrons can move 2 only. Only 2 electrons can move, not more than 2 electrons. They just keep on moving. Okay. Now, just if you go for lithium, Lithium, lithium. So lithium atomic number is 3. Now here you see, this is shell number 1, 2 electrons are there. Initially in the center there are 3 protons. Now 2 electrons are revolving in the first shell, but here the atomic number is 3. Now what about the third? So third will revolve in another shell, that is shell number 2. If it is K, then this is L shell. What is this? L shell. Either we can say shell number 2. So here in L shell, the maximum number of electrons can revolve is 8, not more than 8. 1, 2, 3, 4, 8 electrons can revolve. But here the question is lithium. So how many electrons will revolve in the second shell? Already, because the atomic number is 3, 2 are there in the first cell, so remaining 1 will revolve in the second cell. Only 1 electron. So this is the structure of an electron dot structure of lithium. Okay. Now take the example of sodium. Sodium is Na, the atomic number of sodium is 11. So what will be the structure? You see, in K shell we have 2, maximum 2 electrons. So here 8 shell will go, 4, 5, like this. Okay, 8 cells are revolving in the second cell. Not 2 plus 8, not more than 8, because it has the capacity to revolve, the maximum capacity 8 electrons will revolve in the second cell. Now it's 2 and 8, 2 plus 8 is 10, but here is 11, so we require one more, so that will go in a third cell. So that cell, K cell, L cell, M cell. Okay, so that is cell number 3. Now here like this they revolve. Means if it is the outermost, say here for sodium it is the outermost cell is the M cell. In outermost cell there must be 8 electrons for the stability of that atom. 8 electrons must be present. If 8 electrons are present in the outermost orbit, then that is called octet. Octet means is a Greek word for the number 8. 8 electrons should be present in the outermost shell. If it is a not stable. It is not an inert one. So here sodium has 11, so its electrons will arrange in this manner. Now take the example of chlorine. Chlorine, I think 17. Now 2 is already there. So see, the arrangement will go in a mathematical calculation as 2 into n square. What is n? N means it's a number of shell. For first shell, n is equals to 1. For second cell, n is equals to 2. For third cell, n is equals to 3. See, for n is equals to 1, so for K is the first cell, 1. So 1 square is 1, 2 ones are 2. So in the first cell, in the K cell, it is 2. Now L cell. L cell means 2 into n is equals to 2. That means 2 square is a 4. 4 2 is a 8. The third, M cell. 2 into n is equals to 3. Means 3 square. 3 square means 9. 9 2 is a 18. So maximum number of electrons can be accommodated here in the third cell is 18. Not more than 18. If suppose less than 18 are there, then what we have to do? Just we will make it 8 electrons and the remaining we will go for the fourth cell, because 8 means a stability of an atom. We require octet. Octet means 8 electrons must be there in the outermost orbit. Okay, now this is the way how the electrons are arranged in an atom. So for this you should be well practiced with the atomic numbers of all the elements, and with that I think you can do. So we can also arrange in that manner. For lithium, we can also write in some manner lithium, for lithium in the K shell, L shell, M shell. So we have 2 in the K shell and L shell 1. So for it is sodium 2, 8, and what is left? 1. So M shell 1. So for chlorine 2, 8, 10 and 7, 17. So like this also we can arrange in a tabular manner, K shell, L shell, M shell, N shell, isn't it? So this is how the electrons are arranged. These are the simple process in a school level how it has to be explained, but when you will go to the higher classes, their subshells are there in the electronic configuration. So the actual system of electronic configurations will be entirely different from this. When you will go the higher classes, at that time I will explain. So till then you just go through all the atomic numbers and try to arrange in this manner. So okay, so we will see you in another video with another interesting topic. Till then, bye.